Alright class, today I'm just gonna show you some technique to basically start to do the low level design for a software application. Now very quickly, let me open drawer.io. Okay, create new diagram, software there, and then there are already some template that you can pick from. Doesn't matter if you pick software class 1 or software class 2. Let's just pick the first one. Create. Now they already create some of their basic thing for you. Um, but very quickly, if you click on the left here where it says UML and scroll down, I just want to call out three things when it comes to UML diagram. First, it's gonna be the extents. These are meant for inheritance. And then you have composition and aggregation. I will explain what each of those mean, okay? Alright, so let me just very quickly remove all of this. Okay, all of that. This as well. And this as well. Alright, you probably have heard that when you first design application, we are actually trying to solve a problem by engineering the solution into software application. But how do you understand the problem is the key. So very first thing is you have to do abstraction. Abstraction is just basically you're trying to mimic real life object into software application model. So assuming our bookstore that we ordered the software architecture for, before I even design the low level, I would first start out what is known as the data model. For my bookstore, I would just have, let me just use class name for now. Right. So for my bookstore, obviously I will have books, right? And I will have customers, right? I will also have author. All of these objects usually are now, right? You're trying to model everything that all the entities that will be involved in the bookstore, right? So very simple. First thing is I would try to do them by try to identify all the entity by use cases. If one of my use cases is the customer should be able to look at their different book when they go to the home page, then obviously just within the statement alone I have customers, I also have book, right? Notice the and then so that's already two entities. Now if another scenario is the customer should be able to check out the book and actually pay for them. Now that use cases help me to know that I will need another object. When they check out, obviously they're trying to pay for something, so payment information, right? So let's just start with those four. So now I have those four. These are my object. Don't worry about the field and the method. Let's just focus on the name. Alright, so these are for object. Very quickly, for UML diagram, you would have association. Okay, so these are association. Okay, then you also have aggregation. And composition. For implementation, They pretty much for you to implement interface is really similar to generalize, but don't focus too much on this. Just extension. Oh, sweet! I already have to work for me. Extend. This is also known as generalization, and I walk through what each of these mean. For all association is literally just mean how is this object or entity relate to this object. How does customer relate to payment? How does book relate to authors? Okay, so if I just move this association up here, right, the arrow should really be this way because my use cases is that the customer should be able to look at different books, right? So from customer to book, let me just write it here. Look at different book. Customer look at different book, right? And book obviously will have author, right? Book has author. Customers can also check out book, but when they check out a book, they need to have payment. So from here, customer initiate a transaction, right? So actually this should really be check out, and then customer will have different payment setup in their account. And payment information. Okay. Customer can check out. Customer also have payment information. Oops. No, there we go. Alright. So those are just the association. Now, from all of these association is where you were trying to reason it among with yourself is if this association is a composition, or this association is an aggregation, or the association is an extension or generalization. Okay, so very quickly let me think of some. Alright, so obviously the website. Right, we also have support staff, right? Your employee. So support staff, right? Support staff will probably is the one that will look at our checkout process and support customer if they have any question. So okay, I'm just trying to basically show you that you need to identify all of the related model in your system first to start out with your UML diagram. Now, these are association. Okay, a composition is a composition, aggregation, generalization, or just specialized association. For example, if something is a composite of something, that means the object cannot exist without the other object. So let's do this really quick. Assuming I have dog and let's say tail, right? Right. Then obviously the dog has tail, right? That is one association, but that association, if you really think about it, is you really cannot have a tail without it attached to an actual animal. So that relationship is really is a composition. If you show me something like this literally means that dog has tail, and the tail cannot exist without a dog. This literally means must belong to. Entity dog must exist in order for tail to exist. Right? Make sense? Aggregation have similar meaning except the two entities can exist separate from one another. So now I would say dog would obviously have owner, right? The relationship would be aggregation, right? You can have stray dog, you can have runaway dog. I don't know. You make your dog mad so it run away. But this would be aggregation because a dog belongs to an owner, but a dog doesn't need an owner for it to exist. However, a tail of the dog need the dog to exist before the tail can exist. You cannot just have a tail out of nowhere, right? So that there are differences between aggregation and composition. When something when a bigger object, the bigger object composite of many little objects. For aggregation, it's just the owner. Every little object aggregate together to form this bigger object. So owner has dog, but dog can exist without owner. That is aggregation, right? So that is what you would call an open relationship. A tail cannot exist without an animal. In this case, the animal is a dog. So this is a closed relationship. This tail cannot exist without a dog. I go back to the bookstore in a second. I just want to make sure you understand this first. And then now for extension or generalization. These are pretty much what you would refer to as inheritance, right? So a dog, whoops, that's kind of far. Let me just take this out. Whoops, now the whole thing gone away. Alright. A dog could be an extension of this animal, right? Extension just means this dog is an animal. So when you look at these specialized type of association, an extension or generalization should be an open arrow, and you would read it as a dog is a animal, right? So this really is a dog is a animal. A dog has tail. A dog belongs to owner, right? Really, composition aggregation is literally has all belong to. When something belongs to something, that means it can exist without the other object. When something is a composite of another thing, that means that something cannot exist by itself. So for a vehicle and your tires, they would be aggregation. A vehicle has tires, but tire can exist without the vehicle, right? So pretty much that is extension means inheritance. A dog is an animal. A tail must belong to a dog, and a dog could belong to an owner, right? Something to call out is that generally, well, because this is not an object-oriented class or not a coding class, but if you have something like this, if you have an extension, that means there must be some common attributes that the animal has that will be passed down to the dog. Okay, so for example, you have dog that extend from animal. You may also have cat that also extend from animal, right? Now, what are some now back to the class object, field and method. Field is all the attribute that this object can have. Notice I say attribute, and these are the methods, meaning these are all the operation that an animal can do. So if I say for my field, I would have, let's just assume for an animal, I would have tail color, right? Tail color. You, because this is object oriented, because this is just modeling, you don't really need to give me all the different data type. I just gotta just show me the attribute. That should be enough. And for the method, obviously you would have your setter and getter, so you can set the color of the tail or get back the color of the tail, or in this case let's do some behavior. So let's just say bark, right, is what, well, not all animal bark, so let's just say eat. All animal eat, right? So for animal, tail color, because cat and dog inherit from animal, tail color will also be down here in the cat and dog object. And similarly, the eat method will also be here. Okay? Now, the dog and the cat will only inherit these attributes if the type is public or protected. I don't want to get too much into that. It may be confusing you. I really wish or really want you guys to just be able to draw this very high level model. I'd be super happy if you can just do it well. Don't worry about protected, private, or public. Assume everything is public. That's probably the easiest thing. Everything else, you get used to it as you indulge yourself into the work environment and learn more from your peers. Okay, but now because those two inherit from animal, they also inherit the attribute and the behaviors. Okay, they can also have their own attribute and behavior. What is it that a cat has that a dog doesn't? For a lack of better word, I'm just gonna say that a cat can have 9 lives and a dog doesn't. That's kind of bad, but yeah, you know what I mean. So I would add one more to this. Duplicate. Whoop, wrong one. Duplicate. Here we go. Move into tail color. So I would say number of lives, right? So that this attribute only belongs to the cat. It won't belong to the dog, right? What is it that a dog has that a cat doesn't? Let's just assume the dog have horn and the cat doesn't have horn. So just drag it back in here. Yeah, right. This is some sort of angelic dog. Make it like a unicorn dog horn. Right. So just an idea, right? So this symbol open triangle meaning inheritance, meaning this is a generalization. Dog and cat are generalized into animal, right? And when something is a generalization of another thing, that means their parent entity both the attribute and behavior of the parent entity will be passed down to its children entity, right? So animal has tail color. Tail color, sure enough, is a trait or characteristic that cat and dog inherit from their parent. Same thing for this behavior, eat. Now, cat and dog may eat differently, but the behavior comes from their parent. Just like you and your sibling, one of you may be left-handed, one of you may be right-handed, but you still eat using your hand, right? And you inherit that behavior from your parent. Maybe a bad example, but you know what I mean. um, Composition meaning the object cannot exist without the object that is dependent on first exist. Aggregation just means both entity or object can exist without another. Okay, so that's what it is. Now going back here, after you have all of the association, now trying to see if you can specifically categorize them into either extension, composition, or aggregation. Okay, delete. Alright, so now what? Can a book exist without a customer? Yes, but can a customer have book in here? Doesn't really make sense, right? So this association cannot really be categorized into any of them. Book and author. Can a book ever exist without an author? The answer is no, right? Author wrote book, so book belong to author, right? And so this relationship would be a composition because book cannot exist without an author. So you would do that. Okay. Now, can you actually have like an invoice or checkout without customer and without book and without payment information? Alright, what is needed for you to be able to check out something? You need to have the item that the customer want to check out. You need to have the actual person involved in the checking out, right? You also need to know what kind of payment will be involved in this checkout process. So that means book, customer, and payment information, because those three can exist by themselves without the checkout to exist. They would be aggregation. They aggregate together into the checkout entity. The checkout entity consists of book, customer, and payment information. So, and obviously, if you have any question, you can always email me and I will explain it to you to the best of my ability, right? Okay. Now, what is the relationship between customer and payment information? Payment information must really belong to a customer. You cannot just have a payment information without having a customer. And so this would be a composition, right? Payment information belong to customer. Support staff literally just want to support the checkout, support customer whenever they have any information. So there's really no aggregation or generalization there, right? Because support staff just want to run the website, do all the administrative tasks. So they will still be pointing to the customer without any special relationship, right? Now, if I'm gonna have first for attribute customer, I would have first name, possibly last name. Right, just right click duplicate and then move it back into this region. Last name, and method would be checkout book, right? Or view book. Customer can view book, just right, view book. Okay. For method or operation, you usually would need to have parentheses around it, right? Now payment information would more than likely be credit card type, and this would be method is charge, credit card type. If you don't know what method to give to your object, you can simply just provide the getter and setter. They will still count. So credit card number, and one of the behavior in here literally just get credit card number. Okay. Support staff just support book. All these are now very generic. Support staff will also obviously have first name and last name. Whenever you see two different entities that can share attribute, it is best to generalize them into a more generic object. So in this case, if I really want to, I can have both customer and support staff to inherit from just person, right? Person that first name, last name, and they would inherit from this object, person. Now I would move first name and last name there, and I would delete this here. I don't want to write it in two places, right? This let me know that first name and last name will be passed out to support staff and customer, right? So these are very basic, the low level data model of your object, if you will. For discussion 4, I asked you to try and see if you can relate the institution, university, professor, student, courses together. Show me how those entities relate to one another. You can do something very similar to this one right here. This pretty much whatever data model that you come up with ultimately will become the database model, right? So a lot of time data modeler would also give what is known as the multiplicities between those objects, right? But you really will learn that in your introduction to database class, and I don't want to give you too much information to confuse you. Some of you are pretty much far ahead or advanced, but again, this class is for undergraduate, and then I'm approaching it from the standpoint that you don't know anything. And so I'm trying to teach you as basics as possible information that I hope will stick with you. And I think if you understand this much, at least being able to reasoning with yourself whether an entity is a composition or an entity is an aggregation or simply just inheritance, then that is good enough. The next recording lecture, I will show you how you can do sequence diagram, right? Because really, when I hand a UML diagram when you hand this to any of the developer, they would, based on whatever attribute you have and the data type that you want, string, integer, double, or the method, encode that this entire entity for you. right? So one, use your use cases to help you to identify all the entity. Once you have identified all the entity, trying to relate them together. Now, finally, when you already have all the entity identified, now you need to determine what are all the feature or operation that your application support, right? As an example, if you say a person will be able to view all the books, then behind the scene, for the person to be able to view all the books, you would need to let the user log in. So your application needs to have some sort of login capability, and you will have to model it somehow. And after they log in, after you authenticate the user and make sure they have the right authorization, now you need to connect to the database and fetch back all the books that your bookstore currently has, right? So that's already two operations. Person want to view all the book. The two operation is one, person must log in, so you need to have a login code or login model. Two, you need to have a database. You need to connect to the database and pull back all the books that your bookstore support. All right. Now, if you really want, let we. Well, I don't want to give you too much information. This is used for discussion 4. I will make another separate video to show you how do you now model the operation that will utilize all of the model that you have. Okay? Thank you. Bye bye.